Hey, what's up, YouTube? We're gonna be continuing with the blind 75. This one's gonna be an exciting video because this is the end of the array section over here. We're gonna be solving the threesome and container with the most water. So let's start off with the threesome, and stick around. Okay, so let's start off with a threesome over here. So this is similar to the two-sum question. So given an integer array nums, return all triplets, blah blah blah, where that they all equal to 0. This is similar to the two-sum. So you could brute force this, and do an n to the power 3 runtime. Big O of n to the power 3 runtime, but that's really inefficient. So we're going to do this in a different way. Let's just copy this example over here and bring this down. So one thing to notice is that it says that there's no duplicates, right? Notice that the solution must not contain duplicate triplets. So -1, -1, 2. You can't return 2, -1, -1, or any of the orders. One order is just one way. So you can do this with the brute force method. The other thing is that you'll have to keep track of duplicates, so you'll have to keep like a map or something, or some sort of way to sort of make sure that as you are iterating over this in the most brute force way, which is log n to the power 3, big O of n to the power 3, you want to check that you're not adding duplicates to the answer. Another way we can do this is to first sort the array. So this over here will become -4, what's it, -1, 0. Let me put a thing over here. 0. What else do we have? Oh, we have another -1, and then we have 1 over here, right? So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. We're missing a 2. Okay, cool. So the way we can do this is a 3-pointer approach, where we keep a reference, we keep a pointer to the first 2 over here, and we start one to the very right. Because in this case, if you add both of these together, you will need a high positive value to help compensate for this, to bring it back to 0. So that's why we keep a pointer over here. So let's say this is -1 and -4, -4, and -1. You can start from over here and essentially keep traversing down to try to find -5. There's other ways where you can like make this algorithm faster by checking whether the value over here, let's say value k, is while it is greater than the sum of these two, you want to keep iterating down. But we're not gonna worry about that because that doesn't add too much of a optimization. We're just gonna run with the 3-pointer approach. So the first thing we want to do is we want to iterate over it. So range of nums over here. So now one thing is that with duplicates, we kind of don't want to, like if this was -4, -4, -1, 0, 1, 2. So let's say you have -4 and -4. Here you have these 2 pointers, I and j. So now you need to find a -8. Let's say, sorry, an 8 over here. So let's say you find this over here. Once you go on to the next one, you sort of don't want there to be another -4 and -4 again. So this will move up after you find 8. It'll move up, and now it'll be over here, and it will check this. So what you want to see is whether the previous value also doesn't equal to the same thing, because if it does, that means you already checked it. So one thing you're going to do is first, if I does not equal to 0, because we're going to check an out of bounds thing, and nums at I, so this is a while actually. So for I is equal to 0 and I is equal to nums of the previous one, we just want to increment I over here. So I just realized that the for I over here, this doesn't really modify this. But a way to skip modification is we can just say continue, right? Because then I will just continue over this for loop and then it will just go. Um, and then this will have to be if. Cool. So now we have that. So now I will just increment to a 1 if the previous value is the same. So let's say over here and the previous value is also 4. We can skip because that means we already checked this. So now what we want to do is take the next number. So j is equal to I plus 1. And then k is equal to the length of nums minus 1. And now you want to do the while loop where j is less than k. And I keep forgetting that this is Golang. Another thing we have to do is that we have to make sure this is sorted. So what we're going to do is we're going to say sort ints by nums. I'm going to see if this works afterwards. There's a sort function that that Golang has. Okay, so essentially you're saying if nums at I plus nums at j plus nums at k is equal to 0, that means this is the three values that actually is the answer to one of the three sums. So then three sums. Three sums, yes. So res is equal to append res, and then we want to append the three values. So that's nums at I, nums at j, and then nums at k over here. So once we do that, we also want to iterate, we want to increment I. So I plus plus. Okay, so let me just bring this down to a regular for loop then, because I will not increment you to the range function doing its own thing. I'll change that later. So I'll just say, okay, so we found this, and now we just want to increment I over here. Sorry, no, we just want to increment j over here. And then we're just going to say for j is less than k. We want to do the same thing that we did over here, but for j. Because we don't want duplicates because we already found one of them. So nums at j is equal to nums at j minus 1. And then we just want to do j plus plus over here. So now cool, so we did that. Another thing is we got to bring this in over here. Yep. So let me bring that up. So now otherwise, if nums over here, we want to check whether it's less than 0. So if it's less than 0, then we want to, if it's less than 0, that means now the value of that means k is not high enough. So then we would have to move up j by a pointer, because the more you move j up, it's assorted. So we'll try to get a higher value. So you do j plus plus, else k minus minus. And that's pretty much it. And then it'll just keep iterating over this to find it. It will just keep iterating over the array in a 3-pointer approach. One thing I said I would do is I would make this make it a regular for loop. So I is less than length of nums minus 1, and then I plus plus. Cool. So now it's regular for loops over here, and we finally return res. Okay, let's see where the syntax errors are. It's an extra weird square bracket here. Oh, else if. Okay, I don't know how to declare this. Undefined sort. Okay, tell me I can't get a sort function in here. That would suck. Okay, there we go. We can get a sort function here. Okay, cool. So that is the answer for this one. Let's see if it works for the entire data set. Yep, it does. So over here, we've solved this question over here by first sorting. So sorting over here, given that it's the best sort, would be n log n, and then we would be iterating over this in a pointer approach. We'll be seeing each of them. Another thing you can do to optimize this again is in this else statement. Um, oh yeah, you can bring j up, so it doesn't really matter. I guess if this is too positive, if this is greater than, so you can say if this is greater than 0, then you can't really do much, to be honest, because every number you'll increment by will get larger, so you can skip that. So that's a way that you can sort of solve for this. But that's how you solve this one over here. Let's move on to the next one. This one is the container with the most water. So you're given an integer array height of length n. There are vertical lines drawn such that the two endpoints at the ith line are I and 0 and I and height. Find the two lines together on the x-axis to form a container such that the container contains the most amount of water. Return the maximum amount of water a container can store. Notice you may not slant the container. So over here we're given this array, and now we can't really sort this array or do anything because we got to maintain its order because we're trying to find the width times the height. That's how you get the area for all of this stuff. You can find the width by checking its indices, so that's a great thing. And essentially, so for this example over here, the most water you can contain is this 7, because if you take this height over here, which is 8, and this height over here, which is 7, if you imagine you're filling water in, it can only go up to a maximum of 7. So 7 times 1, 2, 3, 4, 5, 6, 7. So 7 times 7, the width times the height is 49, and that will give you like the maximum. So we can check for this one too, which is 8, right? So this is 8 and this is 8 over here, but we have 1, 2, 3, 4, 5. 8 5s are what, 40? Yeah, 40. So 40 is less than 49. And then that just doesn't, that's not the maximum area. So that's how you gotta work with that. So we'll need the two-pointer approach again, because we'll start from the outsides and then work ourselves in. That's gonna be the fastest way, really. So we're going to do start, end, and max area, and that's equal to start is equal to 0, and is equal to length of height minus 1, and then max area we're going to say 0. So for start it is less than end over here. We're going to do the calculation over here. We're gonna get the min height, right? The min height is gonna give us the height that we can multiply by. So min height is equal to math dot min, and we pass in the float 64 version because we can, because min only does that. I'm so glad I learned about this, honestly, because I would do this the longer way. Float 64, and then min height would be a 64 over here too, but we can change that later. So now we got the min height. Now we have to find the width. So the width is equal to end minus start, which is that. So that'll give us the width, and then we can do the area is equal to width times min height. In this case, we need to cast min height. Min height And now we got the area. So now we have to see if we have to see if this area we got, if area is greater than our max area, then we do max area is equal to area. Now we need to move either the start or the end closer. Now, which one makes more sense? We have to move the height, which is the smallest, up. So we have to do if height at start is less than height at end, right? If the height at start is lower than the height at end, then we can move the start over. Else, we will move the end over, but we can't really increment end. We have to decrement end by 1. And then essentially we just return the max area over here. Let's see, I try my best to make no syntax problems. Let's see if that, let's see how good I am. Output 7. We didn't make any syntax problems, so that's great. But we did something wrong over here, so let's see. Oh, we forgot. We need to get the height at these. And gives us the maximum. Cool, so that's passed. Let's submit this and see what we get. Cool, and this passes. This is faster than 96% of all submissions, and the memory allocation, those are really good. I remember solving this a long time ago. This is one of the problems I had no problem with because I solved this such a long time ago, and I remember the general way to do it. I remember the first time I solved it, it took me way too long. But that is the end of the array section over here. I'm so glad we did it so fast. In the next videos, we're going to be solving the binary, the dynamic, the graph, interval, all that stuff. We're going to try to be going through all of these. I hope you enjoyed this video so far. If you did, show your support down in the likes and comments section, and I'll see you in the next video. Peace.